This video is to show you how to do work cell balancing or determine the required number of workers, which looks at tack time as compared to cycle time. This concept is very similar to the third video that we have for Chapter 9, where I'll talk about assembly line balancing, where we talk about the creation of workstations. But remember, with this idea that we have a fairly simple process here where we go from activity A to B to C to D to E, and they're all in sequential order. And so this idea here is if one worker were to perform these tasks, this is to produce a product. There's a shear, basically cutting it, bending, welding, cleaning, and painting. And so if one worker were to do this, it would take them a total number of minutes. And so let's calculate that out because we need that piece of information. So the sum here of time, if one person were to do this, it would be 8 minutes total. Now, we first of all need to calculate tack time. And tack time is where you take the minutes available per day or whatever unit. So we have the task done in minutes, and so we need to know what it is in regards to our workday. So if we were to be given hours, we would need to convert that into minutes, or if we were to be given hours and this was in seconds, we would need to convert them in seconds. So they all need to be in the same unit of measurement. So they've given us our workday consists of 420 minutes. We need to produce 250 units per day. So let's calculate the tack time. Tack time is the same as cycle time, as you'll see in the third video, but we use a different term to distinguish between the two procedures. Tack time is always the much simpler process where we're looking at just the number of workers. In the more complex process, we'll look at the cycle time, which is calculated the same way, and look at the minimum number of workstations instead of the minimum number of workers. But tack time, we take the minutes available per day. In this case, we have 420 minutes, and we divide that by the output. So we need to produce 250 of these units per day. That tells us that we basically need to produce a unit in 1.68 minutes. Now we have a problem here because you'll see that it takes one worker 8 minutes to actually produce the unit, where we need to be producing one in every 1.68 minutes. And so we need to figure out how many workers or cross-trained employees we need to do this. And so we would take then this idea where we would number of workers, and we are going to take then our total amount of time here, and we're going to divide it by our tack time, and that would tell us that we need 4.76 workers, and of course we're going to round up, and so we would say that we need 5 workers. Now think about this in regards to the actual process. One worker could be assigned to shearing, another worker to bending, another worker to welding. We would be a little bit over, but we might be able to save a little bit of time, 0.02 of a minute. Cleaning is going to be our problematic one. Painting actually will have a fair amount if we assign one worker. And so in reality we need 5 workers, but what we really need to think about is seeing if we can simplify the cleaning process. And what that may mean is that the worker assigned to painting has to do the final cleaning, and so we can take some of the time associated with cleaning here, 0.68, and add it to this one, and so that therefore this worker would have 1.68 minutes of work. So they would do the final cleaning and then paint it. And then, of course, shearing and bending, if they could take some of their idle time and also help out with the cleaning. theoretical minimum is 5 workers, but we need to get this cleaning down to the point that that it can be effectively done, or that the remaining amount of time, so that each worker is doing 1.68 minutes of work. And so we talk about priming the system. Yeah, the first time through, it's going to take 8 minutes for a product to come off the line. But think about that. After the worker here is done, they're going to pass it on to the next station and then start on the next unit. And so once we've primed it, once we've gone through it once, then every 1.68 minutes we will have a unit coming off the line, and that will help us to produce 250 units per day. And so that's the idea of work cell balancing, or determining the minimum number of workers for this very simple process. In the third video, we'll talk about assembly line balancing, where we have much more complex processes.